Oh, I forgot my wee clicker thing, so I'll have to kind of stand here and talk. Right, so, kia ora, welcome to the second lecture. We seem to be a bit thinner on the ground than we were on Tuesday. Is the fact that I'm streaming to Twitch and Discord mean that some of you find that moving up the hill too difficult? Well, maybe. We'll see how this goes. I don't mind how you learn, so long as you learn. Right? I don't require you to be in here unless I'm helping you learn. Right? If being here helps you learn, fabulous. If you learn just as well through there, hello people online, that's also fabulous. Right? So I just want you to learn stuff. Now, I have to get my mouse in the right place. Right, so a couple of wee housekeeping things. One is we are going to be using Git. We are using GitLab, the ECS GitLab. We yesterday created the assignments directories for you all under coursework. So now if you go and have a look at Fork, you'll find the drop down has coursework CGRA252 as an option for you to put work into, and that's for both assignments. We desperately want you to use LFS because if you commit, because we're about to up your gig limit to, I think at the moment 5, possibly 10 gig rather than 100 meg, because our LFS system gives you 100 meg and then locks you out, and you cannot use Unreal at 100 meg, right? Unreal kind of defaults to 2 gig, kind of regardless of what you're doing, right? Big projects. If you don't use gitignore and you don't use LFS, you will blow out our GitLab server because we'll give you that 10 gig, and then you'll fill up, if multiple of you do this, you'll fill up our GitLab server, and no student will be able to use GitLab at all across the entire department. Okay? So Reese will just delete everything you have there. Right? And so and that's a hard delete, no backup somewhere nice, no, I'll just delete it and you'll say, no. Clean, get rid of that because that's breaking it for everyone. Right? So don't break it for everyone. There could be a dunce hat with shame, but don't do that. So we do desperately want to use gitignore and our git attributes for LFS accurately and well. If there is anything you're concerned about that, ask us before you do stupid stuff. Okay? So that's partly why we have the lab, so we can be there and help you out with a bunch of those things. And use the Discord. Ask us how to do things. Right? Don't muddle through and bash your head against it and hope that you don't destroy things. We also have a solution for students who want this as a 300 level course. We've found the directed individual study that's an ENGA course. It costs a little bit more because it's engineering coded, but if you need this as a 300 level course to graduate this year, then we do have a solution for that for people who needed it, but you have to do additional work and you have to work down with the designers in Tiara, and there's a bunch of additional work we have to do, which then you also would have to do to make this a 300 level course, right? Because we got rid of Comp 313, which is becoming CGRA 359 next year for you guys, which will be a 30-point big project course. But yeah, so there is a solution for that. Right, so the thing, I'm now behind that black area so the people on the stream can't see me. So this was what game engines do, right? So we're talking about game engines. I just kind of bring the slide back up and say we're going to do inputs and output and updates and outputs. Understanding that that's the general mode of what the sorts of things a game engine looks after. So if we look at today, they are very, very large. Right? So these game engines, even the lightweight ones, like Godot is a lightweight game engine with a huge amount of code. Right? There's not a lot of assets in it, but there is a lot of code there. And even lightweight, it's a lot to try and understand and work through. And if you're going to try and read through the entire library, that's going to take you time, right? We don't have that time. So my goal is not to get you to understand every line of code in the Godot engine, right? That's silliness. I am quite happy to dig down into code and have a look at how these engines use libraries and use other code to achieve what they do. So for example, one of the reasons I'm using Unreal and Godot is they both have open source, so we can dig down into those layers. Interestingly, in Unreal, it uses SDL too, right? So the SDL is a simple game dynamics library that you can use. Underneath, embedded in Unreal, is the SDL library for managing events and managing reading and outputs for images. So it's interesting to dig into the code and actually see, oh, I can see how that's working. I had a student doing VR, and he was drawing. Now, you guys did the line drawing stuff last year in CGRA252. Remember we did the having to draw a line as an extension exercise. There was like how you draw the draggies. And you might have heard Bresnam's line algorithm, vaguely told you. Well, my student was having to draw a line in VR on a texture, and he was trying to work out like when I paint, how do I draw that line to that texture? And there was a line to function in Unreal, and it wasn't doing what he thought it should do. So we kept digging down into the code and digging down into the code and digging down into the code, and then we found a comment, Bresnam's algorithm, and it had Bresnam's algorithm written out as the line to algorithm in the Unreal Engine, right? So that algorithm actually is there directly in the engine, right? What we found is that it was the intersection with the surface wasn't where he thought it was. It was intersecting at the top corner, and so the line was being drawn from the wrong position. So we had to change it to center collision rather than edge collision and a whole bunch of stuff like that. Game engines also need to run fast. So sometimes you'll see some very ugly code in game engines. Right? I will work through some examples of some very ugly code with you, which I never expect to see you actually use when you're dealing with other programmers. Right? Because often what you'll find is that you'll go, okay, I want to work out how this works. You go in there, and then you find code which is bizarre, right? And that's because there are ways to do things quickly which aren't ways to do them cleanly. As programmers, your primary job is to communicate your ideas to other programmers rather than just to get the machine to do things fast. Where that's not true is when you're doing game development. So of all the programmers in the degree, in the school, you are the only people who could be justified to do crazy, hacky, dirty, nasty programming, right? I've done a bunch of that stuff myself. I can get low level if I need to, and I can write assembly code. It's generally always a bad idea to do that, right? Because second guessing the compiler is usually a fool's game. You will usually fail to outwit your compiler, and you will not be able to write code faster than the compiler can optimize it. So generally don't try and do that. But when you look inside the engine, you will find there are weird ways of doing things because they are faster. What that means is from the level we're at, I generally will want you to use the engine calls rather than rewrite code yourself. Right? So I was having a look at this in my first years where, because I'm teaching CGRA252 at the moment, you use sine and cosine to generate a line moving around so that you could find the position at the end of the line with sine and cosine, because that's how you do rotate. Well, if you ask AI to rotate a line, guess how AI rotated a line in processing? Well, it shifted the line to the origin, used the rotate function that's embedded, and then shifted it back. Because if you wanted to rotate, there's a rotate function, I'll use the rotate function. Why would I do math when I've got a rotate function? Right? And that's how you treat game engines. You don't rewrite everything yourself. You find the thing the game engine does, and you use it because that part of the game engine will be optimized. It will integrate with other parts of the engine. You'll have those additional tools, right? So it's a mindset moving away from the I'm going to code everything detailed to let's see what tools are there. If the tool doesn't exist, then I will make the tool. Okay, so it's that slight change in thinking. And it caters for a very large array of experts. We have designers who are using these, which is partly why we have blueprints in Unreal, because your game engine is no longer just for all of us in this room as programmers. It's also for designers to use, and for artists to use, and for AI scripters to use, and it's it's got a lot of features which aren't kind of secret handshaking between programmers of the, oh yes, you just have to remember what that command is. That's not the way these work. And they're often built on many, many layers, right? So when we're going through and having a look at how Godot works and how Unreal works, I'll be trying to peel away some of those layers, and we'll be looking at some of what it does and how it does it, and the philosophy behind why it does things. So when we look at modern game engines, and have you all downloaded and opened Godot? Even if you're interested in Unreal, it's still worth doing because it's only like 50 meg. Right? It's teeny weeny as an executable. Still 50 meg of code, right? So it's still a lot. But if you download it, and we have it on here, you should have, and if I get to the right part of my screen, here we go. Open. So when you have a Godot, you should have something that looks, I wanted the whole screen, thanks. Something vaguely looking like that, yes? You saw that, and you opened it, and went, oh yeah, that's a Godot screen. You probably, though, started out looking at it like that, because it starts, when you first double-click it and open it up, it comes up with the 3D tab open, saying, hey, I'm a 3D game engine, honest. And it's kind of, well, actually, you're more a 2D game engine. So it has the tab that shows you. So this way of having, a resources area on one side, a big visual area in the middle, and a details inspector on the other, Unreal looks like that, Unity looks like that, Godot looks like that. They've all kind of went, oh, that's the way people do this, so let's kind of all do that. Right? You can, of course, grab these and move them around and put them where you want them to be and throw them everywhere and have them expand one of them out and all that. You can do things to the interface. One of the interesting things about the Godot engine is this interface is a Godot game. The game editor is written as a Godot game. All right, so they are using their own game engine to run their editor, which means all the code you write, if you add the word tools at the top, will run in the editor, because the editor is just a Godot game. So it has node structure, and it has an animator, and it has all of the elements that are in Godot. Right? So they're kind of using that, what's called a dog food approach, of you use your own tool to make your tool better, because if you're using the tool, you go, oh, that's a problem, I'll fix it. Right? So they've all kind of coalesced to being like this. Godot is open source, which is great, because we can then dig into it. You can, of course, rebuild it yourself. You can fork the repo, bring it into your own machine, and rebuild Godot completely from scratch. We have the option, if you want, we can dig in and start changing bits of Godot. You don't generally need to, because when you build tools for Godot, because the editor is a game, you just write Godot code and you can run it in the editor and run it with pop-ups, and you can have it animating and show additional information in the editor and build your own tools, right? So it's quite effective as a tool building environment without having to implement the code underneath. You can, of course, if you're interested, change things in Godot and look at the Godot bug list, find a bug, fix it, and do a pull request to them, and they could pull your code into the Godot engine for everybody in the world to see. Right? If you're really interested in doing the whole, hey, look at me, I'm an amazing programmer, you should hire me, one option is to pick something like that out of the Godot engine, pick a bug, fix it in the engine, and get it published into the repo, and then be able to say, oh I've helped develop the Godot engine, which would then become true, right? Since you'd got code into the engine, right? So if you're looking at, if you're a bit bored in a summer job or you want to extend yourself, one of the extensions would be that kind of extension, right? Because industry people, when you can point to, look, see, this is my pull request, this is how I got my code reviewed, I understand the process, I understand how to do this, that's a really clear industry indication of that, irrespective of any grade you get out of a course like this, right? So, if you're interested in that sort of thing, it's a place where you can contribute and have that kind of influence. Luckily, Godot doesn't require any install, so down in the, at the moment it's not on the machines down there, but you just dump it onto the desktop and you can run it from desktop. Still good. So it's very small. You can start with a blank project and then quickly build up to functional projects. The 2D and 3D scene, again, because it's all the same game, the 2D scene and 3D scenes you can have in the same game, right? So you make a 3D game and then you can just add 2D content to that 3D game. So when would you add 2D content to a 3D game? Media? A menu. A menu. A HUD. Splash screen. The start screen. Yep.
One of the more clever things I've seen is that taking a 3D game and you put a 2D minigame inside it.
You take a 3D game and you put a 2D minigame inside the 3D game, and that's a kind of fun thing you can do, right? And Godot just very easily does that by having 2D nodes that are just part of the node graph. Yep. You can have a 3D character living in a 2D environment, which gives you an interesting feel and a different mode of gameplay. Yep. Background aesthetic twists. It's interesting because you have to actively control, because what you're doing is you're using world to screen and screen to world. So there's an unproject in Godot, where you can take an object that's in the 3D world that's been projected onto screen, and because the 2D needs to know the position on screen, you want that object to be unprojected so you can find out where it is actually on the screen, so you can attach a 2D object to it, right? So you can use what we generally call like world to screen and screen to world, right? So you say where is that object in the world actually on my screen? And when my mouse pointer is, where is my mouse pointer into the world, right? So those are mirrored functions we use. And yes, using those, you can do those interesting relationships between the 2D plane of the screen and the 3D projected world that you're in. Yep. Yeah, Sean.
Particles?
Particles. Ooh. Yeah, I hadn't thought of doing particles. You could do particles. You could also do some interesting potential like shake effects and like have a kind of HUD-y, that red glow blurry kind of, like Doom did with like the world becoming fuzzy. When you've got blood on yourself, you put blood around the edge of the screen. You can do that as a 2D thing because it's screen related. So there's a bunch of interesting things you can do with that. So 2D is a HUD. You can use that 2D route not for the game, but for other things, as we're saying. And you can add those 2D elements. And you have to work out where the camera is, right? So we can talk about world to screen and screen to world as functions. So Godot's philosophy is that it's very lightweight, it's object-oriented. It's composed of scenes and nodes. Okay, so what you'll find is if you go to Godot, you have this engine here, and I have my 2D scene, and I can create a 2D scene node. And so this is a scene. I can compose scenes with other scenes, right? So I have nodes, can have nodes underneath them, and those nodes can be collected into a scene, but then I can grab that whole scene and treat it as a node in another scene, right? So how this might work is I could create a lamppost with some moss flying around it, right? So I've got an asset, I've got AI agents that are moss that are flying around that asset, and I make that a wee scene. And then I want to have that wee scene in 50 places around my level, right? So I bundle that up as a node, and I just drop that node in all of those places. And then when I change that scene, right, it changes everywhere because those are all copies of that smaller scene, right? Or I can instance them and make them full copies, right? So they either be pointers or they can be deep copies, okay? So you understand the difference between pointers and deep copies? Teaching, you've got enough 261, it's all good. Because, I'm still trying to work out what level you guys are at. So this idea of creating nodes, and here when I add nodes to to this, right? So I can add a child node. I then get a list of a whole bunch of different types of nodes, and all of the, and some of these are expandable. So I get all my 3D nodes, and I can look for nodes to add, and then you can add a character node. So I have character body 2D, which when I creates a child and says, oh yeah, you don't have anything inside that character, so I can't do anything. So it's saying there, the node has no shape, right? So there's nothing to draw. So it can't collide and it can't interact with other objects. Considering adding a collision shape 2D or a collision polygon 2D as a child of this shape. So it's trying to say, hey, it's giving me hints as to what I need to do when I see those error messages. And then you'd create another node where you go add child node. So collision is, so we could do a collision shape, and we can go create. That will then say, oh yeah, I can. You haven't actually. That's good. It's got a collision shape, but it's saying, oh, you haven't actually defined the collision shape. You just said there's a shape. What's the actual shape, right? So a shape needs to be provided, and so over here, you can actually go in shape. I can create a new capsule, is often used in game shapes because it kind of doesn't. Because what do you think the benefit of capsule over cube is?
So if you nick a corner of like an image with a character, you're not getting empty space clipping.
Yeah, so with a cube, you get that corner empty space clipping, so you see the character drawn, and suddenly a bullet whizzes past my head over here and it kills me. And it's kind of, oh, that's right, it entered my clipping zone. That's horrible. Also, another reason, so one is the edge clipping. What's another reason? Yep.
Maybe it's quicker to draw.
No, it's not quicker to draw the capsule. For a collision capsule, yep. Yes, so part of this is moving along a slope, right? Because if I'm a character, right, usually when I come up to a slope, I don't want the far edge corner to be on the ground and me elevated above it and sliding up it on that corner. Also, because that's a sharp corner, if my slope and my ground don't meet absolutely perfectly, then the edge of my rectangle will hit that edge and stop, right? Because it's a tight edge on a 1 pixel high difference in how the slope comes down to the ground, right? Now, if I've got a capsule and that's a curve, when that curve hits it, the curve steps over the edge of that bump and I can just slide up, right? So that's why they use capsules so often, is because level designers make mistakes in how things line up, and you don't want to get caught on a nasty edge that's 1 pixel high or 2 pixel high. I'm sure you've been in games where sometimes you get caught on a 1 pixel high or 2 pixel high thinking, why can't I walk over this? I can climb that wall, but I can't jump that tiny little object. So yeah, those are the sorts of reasons why we use capsule shape. And so if I click there and I do capsule, bang, and we now have in the center here, there. I'm used to using a mouse, sorry. I'm not as good on a touchpad at doing it. So there we have our collision capsule. And you can see from this collision capsule, that whole idea of that curve is going to be much less likely to hit an edge. Right, so now we have a shape. It doesn't do anything, but it's a collision shape. It will collide with other things. So that's that philosophy of being lightweight, compose scenes, nodes, you build up those nodes, you build up those scenes. That collision capsule is childed under another node, so they all move together because they've got a scene graph where each of these nodes, so under this hierarchy up here, each of those nodes is, when it's a child, it gets all the rotations, translations, and scales of its parents. So when you move the parent round, you move all of its children round. Right? So that's the idea of this childing. because if I build a car and put the wheels on it, I want to move the whole car. I don't want the body to move and the wheels to be left over there. That's not what I would have meant, right? And if you don't child those wheels, you'll move the body away from the wheels. So you make the wheels the child of the body, and then you can move the whole thing together. And that's done with the matrix, a translation matrix. So you guys learned translation matrix in 151. You can compose those, and so there's a translation matrix in each one of these, and that link there that you see, that's a translation matrix. Saying, oh, this is the relationship of that object to its parents is the rotation, translation, and scale. So every time it goes down, that's a new rotation, translation, scale, and to find the one at the bottom, you add all of those matrices together. All right, so that's the simple process of what's going on there. So all done with this sort of node graph, scene graph approach, and the nodes. Nodes are not like components, which you see in other game engines, right? So Unity has components, which you add to things, which are a lightweight set of code that will run within an object. Nodes are a full, whole object themselves, right? So they can be the full thing rather than just a lightweight bit of code. So, yes, think of that compositionality as being how Godot works. As I said, the editor is the game engine. If you add tool to the top of a script line, so when you have when we have a script attached, so here you can see I've got a script. If I there's the add the instance, I can attach script here. So when I attach a script and go create, so this is a Godot script. So I've set myself up to be to using Visual Studio Code as my editor. For Godot, there is a Godot plugin. You have to go back and forth and tell Visual Studio, oh, I'm looking at the language in Godot, and you tell Godot, I'm using external editor, and allow you it will spin off the file elsewhere. If I just put in the word tool at the top there, this will now run in editor rather than run in game, right? So it will also run in game, but it will both be running in the game and running in the editor, which means if you have a character moving around or you have some interaction, that now actually happening in the editor itself. You can then do some interesting things because you can add visual elements to, like, say you've got a platform that's moving back and forth. In the editor, you want to see its range, so you can add that information into the platform, but have it only visible in the editor. And you can also make some things show you itself across its full range in the editor, so you can see where it is, right? And you could then toggle it to run it in the editor and test things where you're going to place things by running the platform in the editor, right? So it gives you that ability to go back and forth between those. So if I go back, yep. So that's the tool becoming a simple way to do things. So node distortion tree, the parents are those transformation matrix. Nodes are composed, that composition of translation. There are different types of nodes which have different roles. So here we see the character has a 2D sprite, a collision shaped 2D, and a camera 2D. Right? So these are nodes that are doing different jobs. They're all bound together by being attached to the character. So now that camera, what would be a use for that camera? What would that camera be doing?
It would be focused on the sprite of the collision.
It would be focused on that sprite, so when the sprite ran, that camera would be running with the sprite. Right? So because you've put the camera as a child of the sprite, and so when the character moves, the camera will move with it. Right? You may or may not want that. You may actually want to have code that keeps update, because sometimes what we do is we do a bit of slurping where the character moves and then the camera follows. So you have a bit of a camera delay on that, so you get that sense of I've moved and then the camera's moved to follow me. So there are other ways of doing it, but that's one of the standard ways of creating a character lock camera. And of course collisions do physics, whereas the sprite does display. Now, I made you, well, most of you who did CGRA252 last year, I made you do a side scroller because I'm evil, because I wanted you to do parallax. That was quite a lot of code to get parallax working, yeah? And it was a bit annoying. Right? A bunch of code. And also you had to animate the character, you had to like get those sprite sheets in, and then work out which sprite sheet to be displaying and step through the animation of the sprite sheet and do all that. Yeah, so you do the same in Godot, except it has tools that does that like you have a graphical editor for the sprite sheet, and you can make the environment, you can make the ground using a tile editor that it has. The physics, you paint things with collision areas and you just do it in editor. You bring in those 2D sprites, and it's got a sprite manager where you just say, oh, this is the first, second, third. It just does that for you. It deals with inputs, those keyboard inputs. It has a whole input mapping library that does all of that for you. It has audio handling. You use the 2D to put in menus, which make that really easy. And of course the 2D to do a HUD, which you can just draw as a texture. So what I thought we'd do is have a look at some of how those work. And for the first assignment, which is primarily, I prefer to write my assignments in GitLab or in Git, because they're a README, so they should be a README. And the first assignment is to learn to use a game engine. It is a perfectly acceptable approach to basically reuse the assets from last year and rebuild your game, your 2D scroller. But I'd like to see you push it a bit further than what you had last year, because the tool will let you do a bunch of this stuff much more easily. So the tiles on the grounds, there is a tile set you can add. So if I go to here, we have, in my 2D nodes, I can add a child node, and I should use Control A, and a tile map. Bang, we now have a tile map. And I then have to, add the tiles for the tile map. And my plan is to, in the lab, go through showing you a video of me doing all of this, right? At the moment I'm just sort of talking the concepts of what it is. But here you jump in and you can grab, I don't have the tile map in here, but if we grab we download a tile map, or I move the tile map into resources. So if I, where is it? Not copy paste, where's the open and show in file manager? Bang, down the bottom there. Oh, took a long time. So what you can do is when you, in your resources folder, you'll find that it's got a resources folder. You can see here I've already got my get ignore and my get attributes are already here, because when I commit this, I don't want it to break and I don't want to store stuff in the wrong places. You see we've got the icon, I've got the Godot script there. I can take a downloaded sprite sheet, and do I have one that I downloaded earlier? I think I have one I downloaded. Where did I put that one? Oops, I should have extracted this.
Please clean up the downloads folder.
Yeah, I know. My downloads folder is too big, but you can see there's relatively normal stuff in it. So what we can do that in the lab. I do have a sprite sheet, yeah, buried. Do you want me to do the sprite sheet now or continue? Either or. Okay. We'll do the sprite sheet later. I'll see how my time goes, because I don't want to use all my time just doing sprite sheets. The idea is you take the sprite sheet as a pixel, as a JPEG, you dump it in there, and it then goes, oh, okay, how big are your sprites? So you then have to say, oh, they're 64 by 64, or they're 16 by 16, or something, and that gives me a grid. And then I can stretch that grid and find the elements in here, and then select those to say, oh yes, I want this to be a sprite, I want that to be a sprite, I want that to be a sprite, right? So I want those to be, I want those to be tiles, and it'll take that area and make that a tile, and then you just move to this, you move from the texture to the tile set, and you just dump those tiles into your map and build your map up by dumping tiles in. Right? Or you can write Godot script, which uses the name of the tile and the tile location, and then procedurally builds your level by setting the values of the positions in the tile map to a particular tile. Right? So either you build it manually or you build it in code. It's up to you. Depends on what you're trying to achieve, right? Because sometimes you'll have like a map format in a sort of in JSON, or someone will draw it as a texture, and you want that texture to become tiles. So you have an algorithm that goes through your texture and finds the 1s, 2s, 3s in the texture and says, oh, that's tile 1, that's tile 2, that's tile 3. Right? So you have that kind of way of building a simple map directly, or reading in a data file. The philosophy in Godot of physics is it has its own built-in 2D physics engine. Unreal has its own built-in physics engine. There are other physics engines that you can often use as plugins. So I haven't done the plugins for Godot, but I have seen plugins in Unreal where you use the plugin to do your physics for you. Right? Godot doesn't have a large commercial plugin market, whereas Unreal does, and Unity does. So in Unreal, you can go and actually pay money to get a whole bunch of code that will implement something for you. In Godot, there is an asset environment, but because Godot's free and most of the people doing it are kind of volunteering and open sourcing things, most of the assets are free, so it's not a huge financial market, so there's not a huge kind of pressure for people to make a lot of stuff for it. So it's just not as big. But the built-in physics will do mostly what you would need for a second year level game. Its main job, the main physics collision job, is to deal with the velocity of moving objects. Right? Because it figures mostly what you do in games is you have stuff moving around. You're not looking to do the physics of thermodynamics where you want things to heat up and boil and map how heat is transferred through a substance, right? That's usually not what you guys are doing in games. You're usually moving stuff around on screen and having it bump into other things. Right? So mostly it deals with velocity, and there is a move and collide or move and slide, which is just a function that you call into GoScript to say, hey, physics engine, using all the velocities of all the objects in the world, go and work out what's happening. Right? And the move and slide says, oh, when the character collides with stuff, kind of slide them along rather than stop them immediately. Right? Whereas move and collide says, hey, when you collide, stop that, and I want to know what the collisions are so I can manage the collisions. Right? So there are a couple of different subtleties there. We will have a later lecture on physics specifically, where I go through both some of the details of Godot's physics engine and some of the details of Unreal's physics engine, depending on what you want to learn. Because if you want to learn more about physics, I could do a whole lecture series on the physics of game engines. But that's what you are struggling with learning and what you want to dig deeper into. Right? So I'm interested in adjusting how much of each of these topics we teach based on what you're struggling with and what you need to know more about. So with Godot, what you do is you take all of these characters, right? So when I had this character here, and if I've got to work out how to do this with a touchpad, but it's not designed for touchpad. So this character, one of its properties is its velocity, right? And what you're generally doing as a game developer is you're changing its velocity and saying, okay, here it is, where is it going to go? Right? So I increase, decrease its velocity. Sometimes I can do that on acceleration, and then I let the physics engine deal with what does that mean? What does that object moving in that direction mean to the physics? Right? So you are not running the physics, the game runs the physics. It also does the physics in layers. Right? So there's an important thing to understand about the physics and the system within Godot is that when you create objects, you create layers of objects, and one of those could be the physics layer, so that everything in the same layer will collide with each other, but things on other layers it won't collide with because that's a different layer unless you tell the object you are in all of these layers, right? So here this is the player layer, and so objects in the player layer will collide with the player. So for example, if you want to have grass in the foreground that you run past, you don't want the player to stop when the grass gets to them because that should be in a different layer. So what you do is you put that in the foreground layer and the player will just never collide with that, right? Because it's in a foreground layer. You might have other things collide with it that are also in the foreground, but in the player's level it doesn't collide. The example they use in the documentation is the coin layer there. You might have coins and the player will interact with coins. So the player collides with coins, so there's a collision detection. It's not a blocking collision, so it just registers that something collided and then player picks up the coin. But you don't have the enemies being able to collide with the coins. So the enemies just run past the coins, there's no event occurs, there's no collision detection, nothing happens because the enemy is in a different layer. However, the enemy is in their layer and the player layer, so me and the enemy can interact and have collisions. And me and the coin can interact and have collisions, but the enemy and the coin don't have those collisions, right? So it's that, how do you think of your game in layers as what layer you are interacting with at the moment, and how you run the physics differently on those different layers to do collision detection, to do blocking collisions. So that was a bunch of stuff on Godot. I also want to talk a wee bit about Unreal before, because we are doing high level stuff. So it is C++ and Blueprints. It is open source but not free. It is developing, if you look at 5.2, it is beautiful output, right? I mean, the nanite lumen, the fact that you can dump any size of vertex model in it, and nanite will recalculate that to be triangle per pixel and display billions of triangles in a single scene, means that you have amazing level of detail, amazing lighting effects. It is film quality. It is just astounding. It is taking over the visualization industry. So a lot of architecture firms are now using Unreal. Unreal have been saying, if any of you are technical artists and can make things look nice in Unreal, they have a very large number of job offerings from companies that come to Unreal to say, hey, we need another 100 technical artists who can make Unreal make things beautiful. Right? So there is a lot of work in other industries outside of games for making these beautiful things, because these tools are now much prettier than all the other tools being used by traditional architect firms and filmmaking firms. So yes, we've got the chance to colonize all of those by using Unreal as our engine. This is out of place. This should have been in the Godot thing. Sorry, that's out of order. That should have been before the Unreal slide. Don't worry. All of this was just going to say it does a bunch of audio stuff, right? How many of you are audio people or interested in making your own audio and managing audio in games? No musicians? Not really. So in the past, we have had a collaboration with the New Zealand School of Music, right? So their third year students could do a game audio course and join our third year students to do the audio in games, right? And generally how I ran that is I'd give the audio person 3 or 4 groups who were working, and they'd do the audio for all of those groups, right? Because one group doesn't need a full audio person, because there isn't enough work for a full audio full-time person out of a group of 6. So you have one between like 4 or 5 groups of people. So if you are interested in doing a lot on audio, then we can probably partner up and find a student in the School of Music who would actually be interested in collaborating on making really good audio. Surprisingly, well, maybe not surprisingly, AI is getting pretty good at doing generated audio for a bunch of things, right? And there's a bunch of existing libraries out there that have free audio slicing. And so, yeah, the challenge of audio is that many of you play games with the audio down anyway, because you're listening to your own music. And so your game generally has to play even if you can't hear the audio at all. Right? So because there are a group of players who are their own music on loud and the audio in the game, meh. So that makes audio for many games an additive. However, by doing that, you certainly change the mood of a game and the feeling of a game if you play the game without its own audio. Right? So there is a value in doing the audio well, and the engines now handle that for you. Actually, doing audio yourself, really hard, right? Part of the reason why audio yourself is really hard is because the buffering and the combining of audio and speeding up audio or cutting audio makes it sound terrible, right? So you've got to have really good tools around audio management, and all the game engines do. Both Unreal and Godot, and now Unity has moved more to event-based processing as the core way you do things, right? So their real-time systems use events to do asynchronous communication. You're often used to programming in a very linear way, right? Where you call a function, right? And you write code and you say, all right, go and do that function. And I'll just wait here until that function executes. And then when you're done, I'll come back. Yep, you're used to that style of coding. Mostly in Java, that's what you do. Unfortunately, because there are lots of things happening in games, you can't just kind of do the whole, oh, I'll go and do that and just wait until it finishes. So you have to communicate asynchronously, which means you send events out to things, and then the events are processed. So what you do is you go, oh, trigger that thing to happen, and it will go away, and then you keep doing your stuff, and you just assume that that will happen at some point, right? So that's a very different way of thinking, is this event-based, real-time, I don't have time to wait, I will just fire off events and continue what I'm doing, and the game engine will deal with that collision later, right? And so when you want to go and find something, because you also don't know whether it's in this level or it's been loaded or it's been deleted because it got exploded. So your nearest enemy, I don't even know if there is an enemy in the level. So what you often are doing is you are triggering events and you're saying, hey, I'm going to shout that this is happening. Somebody's hopefully listening. If nobody's listening, that's fine. If somebody's listening, they can process it, right? So we communicate not by knowing where things are, but by shouting events and having people listen to those events, right? So that's a different way that the system is communicating. Now, I only had 2 more slides and I've only got 1 minute left. So we have 2-phase system. So we update everything in the scene trees and then we dispatch all events to all objects. And then all those events are processed and then we update things in the scene tree, right? So Godot works in that way and Unreal works in that way. You kind of plan out all your stuff, you set all your velocities, you set everything up, you send all your events go, and then you step to the processing of all of that, right? And your networking, where you're sending events out to the network and they're coming back, you send them all out and there's a loop that manages networking as a completely separate thread, right? So you don't wait on the networking to finish, you just say, hey, go away, send that, I need to keep going with my game simulation, right? So it's changing your mindset into event-driven programming. Godot and Unity, one of the big differences is who can listen to those events. In Godot, everybody can listen to any event. In Unity, you have to make event listening pairs. But it's still the way it communicates, it's just you know more about the person you're communicating with. In Unreal, you also create custom events and have your blueprints read in custom events. So rather than communicating by going, oh, I need to go to the route, I need to step down the route, I need to find you, and I'm saying, hey, you need to do this thing, right? You go, hey, player, do this thing. And the player's going there, oh yeah, I'm listening to what I need to do. Oh yep, they've said something, right, I'll go and do that. Right? So you communicate via events rather than directly finding the thing and telling it what to do. Right? Unfortunately, lots of you as programmers will think, oh, I need to tell that thing what to do. I will go and find it in the scene and I'll find that door and I'll tell that door that I'm at it, right? And it's no, there's a collision for that. That's a collision event. You respond to an event, you don't get told what to do by another object. Okay, so it's a mindset change in how you interact. Cool, so this afternoon we have 3:30 down in Chiaro, BS201. Apparently all your cards should work and all your logins should work. I'd really like you to come down there and meet some of us and talk through Godot. I will be sitting there doing some Godot stuff and taking you through the tile set and building a simple side scroller. I want you to do that for the first assignment and expand it and make your own game to learn more, either in Unreal or Godot. Okay, any questions? That was all clear? Great. Go and have a look at the assignment in GitLab and try forking, see how it works. Great, okay.